Asynchronous programming is a powerful paradigm that enhances the responsiveness of applications. In this lesson, we will explore the fundamentals of asynchronous programming in C#, why it's beneficial, and how to implement it in your applications. By the end of this lesson, you will have a solid understanding of how to make your applications more efficient and user-friendly. Don't worry if this feels new at first. This section covers what's asynchronous programming. Asynchronous programming allows a program to perform tasks without blocking the main thread of execution. This means that while one task is waiting for a lengthy operation to complete, such as reading a file or accessing a web service, the application can continue to process other tasks. This leads to a more responsive user interface and a better overall user experience. Now, why use asynchronous programming? There are several reasons to use asynchronous programming in your applications. First, improved responsiveness. Asynchronous operations allow the UI to remain responsive. Users can continue interacting with the application while background tasks are being executed. Also, efficient resource utilization. By not blocking threads, asynchronous programming can make better use of system resources, allowing more operations to run concurrently. Finally, enhanced performance. For I/O-bound operations, such as network requests or file access, asynchronous programming can significantly reduce the wait time for users. Let's move on to understanding task and wait. In C#, asynchronous programming is primarily facilitated through the use of the task class and the wait keyword. A task represents an asynchronous operation, while a wait is used to pause the execution of a method until the awaited task completes. This section covers example, asynchronous file reading. Let's look at a concrete example of how to read a file asynchronously. Below is a simple console application that demonstrates this. This slide introduces a class definition. Study the structure in the code sample. In this example, first, the main method is defined as async, allowing the use of a wait within it. Also, the method readFileAsync is called with a wait, which means the program will wait for this task to complete before moving on. Finally, the StreamReader.readToEndAsync method reads the file asynchronously, preventing the main thread from being blocked. Let's move on to best practices for asynchronous programming. To maximize the benefits of asynchronous programming, consider the following best practices. First, use async_all. The way, if a method calls an asynchronous method, it should also be marked as async. Also, avoid blocking calls. Never use methods like .wait or .result on tasks, as they can block the thread. Finally, handle exceptions. Use try-catch blocks around asynchronous calls to properly handle exceptions that may arise from the awaited tasks. In this lesson, we covered the essentials of asynchronous programming in C#. We learned that it allows applications to remain responsive while performing lengthy operations. We explored the use of task and wait for implementing asynchronous methods, and we discussed best practices for effective asynchronous programming. Go ahead and work through this exercise. First, create a console application that asynchronously downloads data from a public API and displays it. Also, modify the file reading example to read multiple files asynchronously and display their contents in sequence. Finally, implement error handling in your asynchronous methods to gracefully manage exceptions.